As you can tell by the introduction, today I'm going to be teaching you about permutations and combinations. Now, permutations and combinations, they go hand in hand, but they do separate things. They both, however, do teach you how things can be organized and when things are in consideration versus when they're not taken in consideration. And what I mean by in consideration or not in consideration, what order things are. So, here I have a little chart that shows the difference between the two. When it's in consideration, that is a permutation. A permutation, when you have that, the equation is n factorial, that's what the exclamation mark is, over n minus r factorial. Easy little simple equation to help you know what to do when you need to do that equation. And now we have whenever it's not taken into consideration, or a combination. Now, a combinations equation is a little bit more difficult, but still pretty simple. We have n factorial over r factorial times n minus r factorial. A little more difficult, but we can still do that. So, if you're wondering what n and r exactly are, n equals the number of items you have or selections you have, and r is ways it can be organized or the pattern it could be in. So, now that we have that information, we need to know what exactly are we going to be able to do with that. So, to be able to know that, you need to know what type of problem you will need to be able to do which one. So, I have a couple of problems that I have ready for you. First one is in a raffle. 7 people's names are in a box. Only 2 can be chosen. How many different people can be selected when the order is not in consideration? Luckily, in this one, it just says not in consideration, so it's a dead giveaway. We have a combination. We need to use the combination equation. Pretty simple now that we know that. So, we have n factorial over r factorial times n minus r factorial. Already decided to write it down to make it a little bit easier. And then I wrote it again, but this time with the variables in place of actual numbers. So, now that we have that, we had 7 factorial over 2 factorial times 7 minus 2 factorial. So, let's get started. First, you'll need to do 7 factorial. So, 7 factorial, I'd rather not bore you and just do a bunch of math for a little bit. I already figured it out. So 7 factorial is 5,040. 5,040. So now that we know that, we can work on the numerator. The denominator, my bad. Now that we go to the denominator, we see 7 minus 2 inside of parentheses. Since it's inside parentheses, we do that first. 7 minus 2 equals 5. And then outside of that is a factorial. 5 factorial is 120. Now that we have 120, we can just multiply it by the 2 factorial. Well, 2 factorial is just 2, because 2 times 1 is 2. So we have 120 times 2 equals 240. So now we have 5,040 over 240. So that just leaves us with one question. What do we do next? Well, now you'd simplify. And again, instead of wanting to bore you with a whole bunch of math and getting a calculator and stuff, I already figured this out. So, 5,040 over 240 is 21. You can double check me if you think I'm wrong, but I'm pretty sure I'm right. So, the amounts of ways that people's names can be chosen when the order is not in consideration is 21. So, now that we did a combination, would it be nice to know what a permutation equation would look like? Yes. So next I have another example, and this one is 5 people are being selected for president, vice president, CEO, and secretary. Only 4 options. How many ways can the positions be filled? So, since it says how many ways can the position be filled, order is in consideration. So, since it's in consideration, we have to use the permutation equation. we have n factorial over n minus r factorial. So, since we have that, I already wrote it down again, and then I wrote it again with the variables in place. So we have 5 factorial over 5 minus 4 factorial. So, let's just go ahead and solve this one again. We have 5 factorial in the numerator, so 5 factorial, just like earlier, is 120. We have 120 over 5 minus 4 factorial. 5 minus 4 is just 1. 1 factorial is 1. So we have 1 in the denominator. And now since 1 is in the denominator, it's just 120, since that's in the numerator. So, the amount of ways that these positions, can be filled when the order is taken into consideration is 120. Well, I hope I did well teaching you a little bit about permutations and combinations. They get a little bit more confusing once you go more in depth, but this is just laying the groundwork, I guess you could call it.
That's all, folks.